Good connections. In this class, we will study good connections. It will be a theoretical class. Good connections are very important because when you are making and doing the design of a good structure, you would like to have connections that look good. And is the architect the one that is in charge to decide what type of connections are the ones that are more desirable, even though the engineer will be the one calculating them. Well, you want to make sure that you have good connections because these connections will help you to make the building to not only work better, but also to look much better. In this class, we will study nomenclature of livewood framing. That is a review of something that we already looked before. We will introduce connections basics, type of connections, and connections elements like nail, bolts, screws, etc. About good connections. First, we need to study a nomenclature. This nomenclature is mainly associated with light domestic framing, but it's not used only for this, it's used for many other structural systems. As you know, usually there are columns or foundations that are supporting main beams, and the main beams are called bearers. And the bearers are supporting the secondary beams that are the joist. In the top of the joist, we will have a floor system. Well, the joist will usually have a shorter span than and shorter dimensions, smaller dimensions than the main beams that are the bearers. In this particular case, because this is a traditional wood system, in order to save foundations and have a less foundation and have a cheaper foundation, it will be more convenient to have foundations that are not deep, but many of them. Therefore, we can look here that the bearer is supporting what seems to be a smaller span, but it's because there are multiple small foundation columns that are supporting it. But usually the longer span is for the main beam, that is the bearer, and the shorter span is for the joist, because the joists are smaller and there are many in numbers. The bearers will carry the load from the floor joist across a large span. Well, as you can look here, next time that you have a building designed out of wood, do not draw in your plans only 2 lines to represent what is the floor system, because that full floor system will consist of a flooring that, yes, will be 2 lines here in yellow colors, and after you will need to have joist that also will be represented with 2 lines. Well, we already have a 3, and that will be in brown color here. And after, perpendicular to that, you need to have the main beams that are cut. Well, please do not represent wrongly, like with 2 lines, like it is like a simple floor made out of concrete. Next time that you are drawing a building made out of wood. Well, the joist will be supporting the flooring, and the flooring will span between the joist, and the stiffness and strength of the flooring using will establish the joist spacing. Well, sometimes it's cheaper to have more joists and have a type of flooring that is not as strong. When we speak about wall frame, we're speaking about the whole element that is the wall that is supporting the roof system and all the loads of the buildings in the different walls. This element is composed by 2 horizontal elements that are in the superior part, the top plate, and below the bottom plate. Between those elements, we have wall studs that are all the vertical elements. In the corners, we can have multiple studs. What happens also when we have windows or doors where we can have an extra stud. After, when we have those openings, we will have a lintel, and the lintel will be supporting a longer span, therefore is thickets. is more thick. The wall bottom plates are the ones that are in the bottom member of the wall frame, and they sit in the top of the floor support members. The wall top plates are the ones that are in the superior part that are carrying the forces of the wall studs, the forces of the roof to the wall studs. And they are part of the wall framing system. Well, we have here some explanation about what the wall studs are. There are the main vertical members of the framing system, and they carry all the gravity loads to the bottom of the walls through axial compression. They are working in compression. There is tension also, obviously, when there is a wind that is tending to put that roof up, and therefore the studs that are supporting the roof will tend to have some kind of uplift. The gravity loads are larger in the lower stories. It's obvious because they are supporting also the superior floors. The stud span between the top wall plates and the bottom plate is normally 1 story. However, there are some kind of system like balloon framing system that allow to have 2 floor heights. They are oriented so that the wind forces place them in major axial bending. Well, the thickest area of that element will be perpendicular to the wind. The lintels are horizontal beams that span over an opening, and is a bending member that attract floor and roof loads from above and carry them to the opening. Sometimes we will need extra studs in order to support all those large vertical forces that are arriving to the corners of that particular element. For the roof, we will have also beams that will be supporting the roof, and those are called rafters. Usually they are inclined when we speak about a system made out of wood. Sometimes they have hanging beams, and they have in the superior part a ridge beam that will keep all of them together. Now let's speak about basic concepts of connections. There are no structures that do not make use of connections. When we have pieces, those pieces and members, those pieces and members need to be connected. Well, connections will transfer the load to the structures from one member to another member. And the connections have to be designed to resist at least the action of the members between them and the elements that they are joining. The connector is the simple fastener or element that is doing that particular work of connect. And the connection is the number of fasteners and connectors that are combined together in order to form the structural component that will give load transfer between members that meet. The codes also use the term joint to refer to a connector. There are many types of connections, and we can look here that we have 2 pieces of wood, and the difference will be the elements that connect them, how they are connected. In the superior part, for example, we have a timber-to-timber connection with bolts or nails. Thereafter, we have a connection with a nail plate. We have a timber plywood connection here with nails. We have a timber heavy gauge steel connection where we have a piece of steel that is connecting, and also timber or double fine plates. And we will be looking them after we understand the 2 types of connections. The type 1 connection is a connection where we have shear in the element. For example, in this element in the left side, we have, for example, a nail or a connector that is putting together the superior part, the above and below elements of wood. One is darker and the other one is a little bit more light. And we can see that the force that are trying to separate those elements is a force that will create some kind of movement between them related with shear. One will slide to the other. The same happens here. We have one connector in light color that is like a column, and the one in darker color that is like a beam, and there is an element, a screw, that is trying to connect them. And what will happen is that the beam will tend to go down, will slide along that column. Type 2 connectors are different. We don't have shear anymore, we have an axial force. For example, this element will not slide along the surface, but will go up when the other element go down. The same happens here. Remember that before in type 1 connections, the element will slide down. Here, the element will go to the left and the other with the right, creating that type of axial force in the fastener. There are different materials to do the connections, and we will speak about them now. The type of connectors start with nails that are very simple, are driving into the timber. They will push most of the fibers apart, and they will not reduce the timber effectiveness in carrying tensile stresses. And the nails will create a friction between the two elements that are put together and allow to create a strong connection between them. Nail plates are used to connect timber on the same thickness in the same plane. Well, they are suitable for both joints connections. In this case, you will have a plate where a machine will just make some elements, some kind of like nails that will be moved 90 degrees and create with one plane that is completely flat, it will be able to create nails in the back. And those nails will be pushed in the wood and will create a strong connector between them. Screws are installed into driled holes. By turning the screw, it will be allowed that the floats of the thread of the screw will be dropped in. And the hole diameter is the same as the raw diameter of the threads. Well, the threads will cut into the fiber of the structure, in this case will be in the wood, and will form a mechanical bond within the wood. And this bond will allow to keep the pieces together. Screws involve the drilling of a hole that reduces the effective cross-section of the timber at that point. Well, the fibers will not be pushing apart like in a nail, but you will diminish the surface of wood that will be able to work as a structural material. Self-drilling screws, such as the type 17 screws, have a hardened drill bit that is in the lowest part of the shank. And that means that the installation is very easy and very simple with a low speed drill. And this will allow a very fast connection between the elements. Bolts are metal connectors that are installed into a pre-drilled clearance hole in the timber. Well, usually there is a washer under the head of the bolt and under the nut that will ensure that there is an adequate bearing on the timber and the forces will be transferred. Well, the idea of a bolt is that will create like some kind of pressure between the material and will not allow the material to slice because the pressure that is created between them. Well, it will be able also to transfer loads from one piece to the other piece because they will work like one unique piece. Because the washer and the nuts confine the timber adjacent to the bolt shaft. The bearing strength on the fiber of the connection is enhanced compared with the bearing strength tabulated for the same spaces. Bolts are ordered by diameter, length, and grade. And only a portion of the shank is treated. So in detailing as a connector, carriers need to ensure that after allowing for the thickness of the washers, there is enough thread thread in the bolt to be able to clamp and connect the elements in a way that is secure. Many times we can have steel plates to allow those connectors to be stronger. We have also coach screws that are bolts that are designed for application in which a bolt will normally be used, but which 1/10 of the bolt is not accessible. Well, in this case, the element will be like a bolt, but will end in a wood thread rather than in a machine thread. And the coach screw should have a clearance hole drilled in the elements that are immediately under the bolt head. One of the inconveniences when we're speaking about bolts, and you will see when we do the calculations, we will do calculations of bolts when we speak about steel, is that the resistance of this type of connection depends on the thickness of the bolt, and the bolt cannot be so thick because you are also making a hole in the material. Well, in order to eliminate this inconvenience, it's possible to have split ring connectors, connectors that are trying to make the surface of connection bigger, and will be like some elements like this one that are rings that are located in the wood and will allow to create a better connection between the different materials. Well, a part of the connection with the hole, where we will put the bolt that is here that we have in the center, where is the dot line, we will have also additional connections around with this nail that will go in there, and that is more convenient. Shear plate connectors have a similar, with split ring connectors that are very similar, but they require also a special drill bit to machine a recess in the timber in order to create that connection. There are different, and we can look here, the difference between shear plate connectors and split ring connectors. Please study this information. We can here see shear plate connectors where we have a plate with a ring that will be connected with a bolt, or we can have here two different rings that are creating a connection between them. In one, we have the plate and only one ring. In the other, we have two rings that are putting together a connection between the elements. And we can see the sections there of that particular elements. Finally, we have metal dowels, and those are elements that can be also made in wood, but the metal ones are more resistant. They are less sophisticated than other connectors, and there is a hole where a metal element will be inserted, and it has the same diameter that the metal dowel and will allow to create some kind of high tensile strength in that area. The geometry, well, the number of parameters will be evaluated calculating the design capacity of the connector. I mean, where the different bolts will be located and what will be the geometry and separation between those elements. Usually the orientation of the force will depend on the axis of the connectors, the angles between the forces, and the grain direction of the material. We will have a number of row of fasteners, a number of shear planes in type 1 connections, and we will have angles that will allow us to create those kind of connections. Well, we can look here an example, and we have, for example, in this superior, let me go back, I'm sorry. We have here a piece of wood that will have 4 rows of elements, 4 columns and 3 rows. And in this case, for example, we will have 6 columns and 2 rows. Well, that depends the type of wood and depends the things that the material can support. For example, if the piece of wood tend to have a grain that is like really horizontal, like in this case, for example, and there are many elements, well, it will be not convenient to have this because you can break, you can have a crack in the superior inferior part of this element that will not work that well. But here, for example, when you have 3 rows, there are less possibilities that that happens. Well, that is something that needs to be studied. We can see here the number of shear planes in the type 1 of connections. For example, here we have 2 members and we have only 1 shear connector between them. And here we have 3 members. We'll have single shear in each of the connectors. And here we have three members, and we'll have double shear in each one of the connectors. This is because the connector will be from one point to the end point and will be traversing the 3 elements. Instead, here is only traversing 2 of them. Well, we will have a thickness that obviously will depend of the type of material and the connectors that we will have. For example, we have 2 members with single nail shear joint here, and here we have 3 members with single nail shear joints, and here we have 3 members with double nail shear joints. And the conventions to define the spacing and edge of the distance will be calculated by the engineer, and you need to understand a little bit what happens. Well, here is the edge distance. After we'll have the spacing between the elements that are perpendicular to the grain, and also we will have the spacing that is parallel to the grain. That's it. That is enough to understand what is the position of those elements, and in the shop, the holes can be made and the connectors can be made. In the case that there are some angle with the force at there are an angle to the grain, well, we will have an edge distance with the top of the connectors, and after we'll have spacing and an end distance that will tell us where is the first of the elements and the spacing between both of them. Like this, those holes can be located. Something important is to understand is that wood is a material that has a lot of water, and the wood will start drying, and it's important that the wood is dry before it's used in order to eliminate effects of shrinkage that will create also some cracks in the material. And when a wood had this kind of problem, it's not convenient to use it. Once the crack will develop through the timber, where we have a split ring or shear plate is embedded, the moisture can access to the connector, and that moisture can rot the wood and create possible a corrosion in the connector. Well, any crack to the wood of the connection will cause a significant reduction of the capacity and the stiffness of the connection. Well, timber in a dry service condition usually tends to lose moisture, and it became something that is called season. And this will have some shrinkage, and in most cases will be pronounced when it's perpendicular to the grain. This is a problem because it means that the ball holes in a single row will move when the element became smaller, because when losing water will lose the dimension will become smaller. Well, the principle of transverse restraint is that one member of the bolted connection has the potential to shrink perpendicular to the grain, and at least one of the other elements doesn't have the same potential because it's cut parallel to the grain. Well, they have different elements, and that will help to create a structure that is more stronger. It's important to understand that the timber does not shrink much parallel to the grain, shrink mostly perpendicular to the grain. Well, we can look here, let me go back. We can look here, the angle of force to grain direction. Well, when we have an inclined force, for example, we will have an angle to the grain, but when we have a longitudinal force, we'll be working with the grain. Well, in the left side, in the left side, we will have something that works better because the force is inclined and it's not going with the grain. Here instead, it can break easily because it's going longitudinal and in the same direction of the grain. Also, when we have moments, it will change. We can have a type 1 moment connection here where this will tend to rotate. Here in this particular case is in the same sense of the clock. And we can see that all these elements will tend to rotate as we can look here. Well, we will have like a centroid connection in this particular case. And we have here a type 2 bolt connections where we will have this type of connection that we have a bolt that is taking all the surface from the start to the end of the element. Well, this connection is very strong in the left side. It's not convenient to have this type of connection. We'll have a screw that is just partial and is not going until the end of the material. This is not suitable for bolts because it will be easier that the material just go to the left side and the other column go to the right side and the connection is broken. Instead, in the left side, this type 2 bolted connection is more convenient. Thank you.